Hello, everybody. Welcome back to our political statistics class. And as I promised, we're going to have today a very brief technical lecture. And the reason of this lecture is that we need to advance a little bit more on the skills that you need to have in order to complete the final project. And these are very basic skills that you need to have in order to conduct any statistical procedure. It is good that you know how to interpret the results that somebody else produces. Like a table, for instance, if you want to read an article, an academic article, you're going to be able to read some of these, at least the descriptive statistic part, and if they have significant tests or measures of association that are not very common, to be honest, in nowadays scientific research, well, you're gonna be able to do it because you have learned how to do it. Okay, but part of conduct a statistical analysis is that you are able to prepare these materials for your own. That's one of the most important things that you need to do, right? So I'm gonna teach you today how to prepare more complex tables and figures. In particular, we're gonna focus today on new skills to prepare more tables. Okay? Okay. So, as I said, we need some. We basically are gonna do, or we're gonna use the same tools that we have been using last time. We're gonna use these packages, Table 1, Tidyverse, and DS Labs, and we're gonna download the CCES 2018 dataset. And also we're gonna use the Gapminder from DS Labs. Okay. Go to R. I have some of these things advanced already. Try to be more effective or more efficient in the use of time. So I didn't, okay. I think probably we're not gonna use the Gapminder this time. Okay, guys. Okay. So I complete the preliminary steps. So we're not gonna use the Gapminder this time. We're gonna use it next time, next week when we study figures. Okay. And this is again like a reminder of where we are. So we talk about this wish list of tools related with descriptive statistics. Remember? So we said that we're going to learn to prepare tables of summary of descriptive statistics, tables with two variables that we learned last class or in lecture number 4. And this week we're going to learn how to prepare tables with 3 variables. Remember that our 3 variables is the basic structure of analysis that we need to have. So we need to control for a third variable, and we need to have our independent and dependent variable. Okay, that's what we're gonna learn this week. And the last week, the next week, we're gonna learn a little bit more of how to prepare bar charts and line charts. We learned in lecture 4 how to prepare histograms, bar charts, and line charts. But we're gonna learn how to do it with 2 or more variables, okay? So I split these topics because tables are to some extent easier to prepare than figures. And it's not really that figures is super hard, but you need a new skill that I'm gonna teach you how to prepare data frames. And there are more details when you want to have like a beautiful or aesthetical figure. So for that reason, I just left that topic for the next class because this lecture is already very, very, very heavy loaded with information about the conceptual dimension with all these significant tests and all these measures of association. So I wanted to have something very brief. Okay, and notice that this is just an introduction of 7 minutes, very long introduction, but it's gonna be very short. You're gonna see it. Okay? Don't worry about watching this video like tomorrow or something like that. Take your time, and this video is gonna be useful for you. There's not gonna be any lab related with this video in particular. So you can watch this video from this point to, I don't know, next Friday. Okay? But this video is going to be useful for preparing your materials for the final project. So don't bypass this video. Watch it because it's useful for you. Okay. So move on. So imagine that we want to, again, explain the support to this policy of provision of universal Medicare for all Americans. Okay, that's our dependent variable, and our independent variable is the approval of President Trump in 2018. And we say that we want to also control by gender. For any reason, we say that maybe women are more likely to support Medicare than men. I don't know. Okay. So the first step, as you remember, when you are preparing cross tabulations on any kind of table, is to transform your variables in a way that is meaningful. Okay. So what I'm doing here is to transform this into a kind of nominal nominal scale. Okay. So that's the first step. So just to this is to remind me is the yeah. So this is CCES 2018 and same name of the data set. Okay, just to remind you, but I think you have this present in your mind because of the first report, right? But very brief. So what I'm doing here is that I'm gonna say to R that I want to create a new variable called Medicare that is going to take the value of one oppose if another variable that is this version of the variable Medicare, the same variable, takes the value of 2, then Medicare is going to take the value of oppose, right? If this variable, all variable CC18 327A has a value of 1, so Medicare is going to take the value of 2 support. Okay? And apply those changes or the creation of this Medicare to the same data set. Okay, this is what the structure of the tidyverse does. Okay, but I think you remember that. So I'm using variables with in green colors, data sets or objects in blue colors, and the functions in bold black. Perfect. Okay. So I say mutate. Oh, sorry. So I say mutate, and I'm gonna create the Medicare. I'm gonna take the value as case when. Uh, takes the value of 2, then remember this tilde, 1 oppose, perfect, and the same, and here's 2, that's 2, this is 1. For some reason, the CCES does the opposite, like the negative values are the first numbers. No, I'm sorry, the positive values are the first numbers, and the negative values are the higher numbers. I don't know why they have that crazy structure. We need to change this. Okay. That's the first thing I do. I create this variable called Medicare. Perfect. Now I have to, so that's my dependent variable. As I said, my independent variable is approval for President Trump, and I transform this ordinal variable into like a nominal variable to some extent. And I remind you guys here that it's important to filter and exclude the category 5 because it's not sure and it's not very useful, that category, at least right now. Okay? So to make this a little bit faster, well, I'm gonna do the filter, which is fine. This structure, and here you write here filter, and you're gonna say that you want to filter by the values of this variable. So you're gonna say that I don't want the values that are 5, which is not sure, right? Yep. You're gonna delete. So now you have less less observations, as you can see here. And okay, that was something that I need to do. Now I create the ordinal version that is here. I don't want to repeat all those steps because it takes time. We created these two variables. We created a approval to President Trump and gender. Okay. Now we need to label the variables of interest. So I created gender, and we labeled with this structure. Remember that this function label is from the package table one. So you need to, of course, have the package table one loaded. Okay. So you're gonna use, I'm gonna copy here too. I've already prepared everything. Okay, so you have just write label, the name of the variable, and the label that you actually want to use. Okay. So I create this. This is something new that I'm gonna teach you. So the package unfortunately doesn't have a perfect function, a perfect between quotation marks, to create. Remember that when we create a control table, what we do, and you need to check that, I think it was the lecture, probably lecture 5, I guess, where I explain how do you prepare a control table, right? According to Pollock. So basically what you do is that you create two tables, two cross tabs, one for one of the levels of the control variable and another one for the levels of the control variable. So imagine that my control variable is gender, right? So I prepare one cross tab between approval of the President Trump and the support to Medicare for men and the other one for women. Okay, and this is important to keep in mind. This it is very useful and is more and it's easier for you, specifically for the analysis when you have as a control variable a nominal variable with two levels or something like that. Because imagine if we had a control variable with 6 categories. It's going to be very difficult to create 6 tables for each level or for each category of the control variable. So it's going to be easier if you have this kind of simple control variables such as gender, for instance, that is male or female or something like that. Okay? That's to keep in mind. So the program doesn't have a perfect function to create that those in a same table, the two mini tables between quotation marks. So what we do is that we create this, you subset the data by female and male. This is kind of a trick in order to prepare two different tables, but it's split versions of those tables. You're gonna see it. But for now, just follow me and create these two subsets of the data set. One controlling for female and the other controlling for male. Okay. I'm going to create a new data set called CCES male. That is basically going to be the CCES. You're going to use filter here. You're going to use filter here and you're going to say, I'm using gender here. Gender equals 1, which is male. So you have here male. And you're going to do the same for female. You're going to create a new data set called female. So that's the next step. So for a control cross tabulation, you have the option to go directly and prepare like at the table, okay? As I said, with table one. I want you to pay attention to the structure of this function, to the syntax of this function. So you have the function table one. The first variable, the first variable here is that your dependent variable, and later you use this operator, and later you have the control variable and your independent variable separated by a plus sign. Okay, that's important. And it's important to pay attention to the order. So it goes first the control variable and later the independent variable. Okay, so you use here the rest of the function is the same, like a data set, and overall total. I'm gonna delete later the column total because this column total is not correct to some extent, and I'm gonna explain why. Okay, and here is the example. So I'm gonna create this new variable with this new table. I'm sorry. So it's gonna be table one, and you're gonna have here table one. So I'm explaining Medicare, and I'm gonna explain it with female. It's gonna be my control variable, and my independent variable is approval to present. I'm gonna use the rest of the structure. Data is gonna be the CCS 2018. You have here overall, and I'm gonna call this total. I just want you to see. Actually, I'm not gonna use this right now. So look at the table here. One of the problems with this table is that this table is fine. Like this is what you saw in Pollock. So basically you have your dependent variable. Remember that always needs to be the rows, and your independent variables is the column, right? And as you can see here, there are like two tables in one table. One table is disapprove and approve, and for the values of men, and the other one is disapprove and approve for the values of women. The problem that you can see here is that this total should be, instead of disapprove, the total of disapprove should be the total of men, and this should be here the total of women. Okay, but somehow, or I don't know why, table one is not able to prepare those correct totals, right? For that reason, I think this that is the first version of the table is not a perfect solution. It's not a perfect table to some extent, but you can use it, and it's nice, and it's good that the two tables are in one table. Okay, for the analysis is kind of useful. Okay, so what I do is that I delete the actually to delete the overall, you write here false. So I'm gonna delete the table. Okay. Okay. So now, if you print T1, you're gonna have something like this, okay? The table. That's the version I don't really like, but it's like aesthetically is nice because you have the two tables in one, but I don't really like it because of the total. And this is the second version of the table. So what you're gonna use here is to take advantage on the two subsets that you created of the dataset. And you're gonna use the subset for men and the subset for women, okay? To prepare the two tables. But you're gonna have like a two split tables, okay? There's nothing else to do here. So I'm gonna create this. So your first table is table one again. So I'm gonna copy this because it's easier. So you're gonna have here the same, but but you're not gonna use female anymore because you're already controlled by subsetting. Okay. So in this case, you're gonna use approval, and if your data set that instead of being the CCES 2018 is female or male, for instance, so you are already controlling by male because all of the observations in this table will be related with male. Okay. Let me show you this. So see here in the environment. So in the environment, you have the CCES 2018 with 57,000 observations, right? When you subset it, this dataset called male has only 24,000 observations, which is the number of men surveyed in the CCES, okay? So you are already controlling, right? You don't need to write here again gender. And actually, if you do it, it doesn't gonna help you in anything because it's already controlled by male. So all the values in that variable will be 0 or 1 or whatever is the value for male. Okay, so you just basically write here, male, and create the table. And here you change this and you're gonna say total men. You create your table and you're gonna do the same, but you're gonna create a new table called T2.2, and you're gonna have here, instead of the data set, instead of being male, is gonna be female. Okay, you're gonna write here total women. You create your other table. Okay, now let's see how is this table. So basically you have here correctly the values. So you have here disapprove and approve for men, like a control for men, and disapprove of Trump and support or oppose to the universal provision of Medicare. Okay, and you have here your actual total of men. If you print the following table, is going to be the same but for women. Okay, this is going to be very useful for the analysis because you have the actual total, so you can conduct the descriptive statistical analysis that I taught you how to do in the lecture 5. And this is going to be critical for the final project. Okay, so pay attention to this because I'm going to ask you basically to conduct the analysis that Pollock suggests, because what you need to do is to identify the partial effects, or first the zero order effects, later the partial effects, and later to identify which kind of relationships are here. If the relationship between X, Y, and Z is spurious, or is additive, or is interaction. Okay? Okay, so that's the first type of table. This is called the control cross tabulation. And you have two ways to do it. The simple way, or not the simple, both are simple, but one way is to have both tables in one table, but you have problems with your column of total. You need to be aware of that. And this is the second way, to have two mini tables. You need to create these two subsets of the data set, but you're going to have the correct columns. Okay, so none of these solutions is perfect, but I think it's very doable and it's very easy. So you know how to print the table.